So hi, so this is the start of my alternator upgrade video using the new friction pads that I've had made. So what's the reason for these friction pads? Well, it's very simple. Two things are that basically, for those that you are not aware, the plates wear and they cause two problems. One is a charging problem, which is the minor issue. The major issue is the particles from those plates that drop into the sump and get picked up by the oil pump. I've seen several oil pumps now that are scored from these plates where the case hardening has basically scored the oil pump. So basically, I hope you enjoy the video. Now, one thing I would say to you, for those of you who are undertaking fitting these yourselves, you need two things. You need a very true and accurate running lathe, and you need a very hard tungsten carbide tip tool, which is solid on the slide, because this tool will push off from the plates as you machine them. I haven't put that in the video, so that's why I'm putting this as the precursor to the video. So I hope you enjoy the video and look forward to the comments. Thank you. Good morning. So today we're going to start the process of resolving and finally sorting out the issue with the CBX alternator clutch plates that cause issues on the CBX. They cause issues in more ways than one. One is they reduce the charging performance because they slip. But secondly, and actually from my point of view more importantly, the scoring on these discs here allows case hardened particles to get into the sump and into the oil pump. I've seen badly scored pumps as a direct result of these plates slipping. But let's really start off with the fix that was undertaken in South Africa. I've not seen it so much in the rest of the world, but I've probably had 5-6 alternators from South Africa that have been welded. So basically people weld these clutch plates together to stop them from slipping. I think personally it's an acceptable solution. It's a better solution than these particles getting into the sump. But that's a personal opinion. You all have your own opinion. I know a lot of people have criticised welding, and I'm not judgmental here. I've actually seen these working. The only problem is because of the clearances here, if you don't get these two plates completely lined, it causes stress on the bearings, and I've seen bearings failed in the alternator as a direct result. But anyway, we're taking it one step further today to resolve this. And the first step we're going to do on this is actually get these plates unwelded by grinding the weld off. But before I do that, I really want to run through the stages of the failures of these plates. So I've got several sets here. This first set here is what I would call probably the best plates I have. There's no scoring on here, and these are what they will look as near as damn it as they came out of the factory. We then go to the next level where we've had some minor scoring here. Now these have been dressed up using 600 grit paper on my surface plate, and the worst is scoring gone flat. Then we go to the next stage where these are probably just about acceptable. Now the problem is some people have these discs ground, but the issue is you have case hardening on here, which goes to a depth of about 0.75 to 1 millimeter. Once they've worn beyond that, then this is just soft metal putty mild steel underneath. So that's the reason why we have to resolve this issue once and for all on these worn plates. And then here you'll see a really badly scored, well actually I've seen worse than this, but this is the worst I can find in the current climate, where it's actually gone. So what we're going to do is we're going to go to the next level now of resolving these issues, but I just really wanted to outline where we are with these plates, so we'll catch up soon. Okay, so we're now going to go through the process of unwelding these plates here. Now what I'm using is a flapper disc on a 4-inch angle grinder, and we're going to go and now remove these welds using the flapper disc. Okay, so that's the welds now removed. Now what we have to do now is try and separate these plates. Now we're going to do that by basically trying to knock this this here without damaging this surface here. So we're just going to go and get a copper mallet and we'll try that out. I'm going to get my mallet. And hopefully we can break the weld on one of these. Like that. So that's it now. We've basically got the two plates apart, and I'll come back once I've removed these plates from the alternator. Right, before we go any further, this shows you the confidence that they had in South Africa of Honda's design. These plates are absolutely in perfect condition, but they've been welded up. So that indicates that actually it was clearly understood that this was an issue in the early days, and these have been welded up for the reasons that I've stated. But this is unbelievable. These plates are almost like brand new, and they've been welded. So that just goes to show where we are with these this design. So anyway, we'll come back once these plates have been removed, and excuse the camera wiggling around. I'm outside at the moment because I've been grinding these plates off. But I'll catch up with you once they've been removed. Catch up soon. So okay, so I've now got this in the vise with the soft jewels on, with the rotor held here on the soft jewels. So now what we're going to do is hopefully, and I'm going to try and do this whilst we video. So that's a 19-inch socket on here. So trying to do things with one hand in video is not fun, but I'm becoming quite well versed in it now. So that's it. So this is how to remove the B plate off the alternator. So that'll just come out now, and you'll see there's the seal off of it. Now this is ready now to put in the lathe and skim. Now I'm not going to be skimming these. These are too good to skim. So I'm cleaning these up, and then these can be kept for a concourse bike if anyone wants to do an original bike. So anyway, there we go. We'll catch up in a bit when we get to the lathe. Okay, so we're now going to start the process of machining this plate. Now the first thing is to make it true. Now I know this lathe runs absolutely dead true. I machined to microns on this. It's an old British lathe, an old Boxford from the early 1960s, but she's in good condition. Now the other thing is you need to make sure you lock your slide off here, because with this case hardening it will push off. Now what we've got to do is, now we could clock this face up, but the problem is these faces distort from heat. And I've now been through and I've tried setting this plate up. There's no point in clocking it because this is a machined face on the back here which the jaw's clamped to. I've done these several times. Now this is running out here. Now what I've done is I've now pushed my lathe tool up to here, and I've just run this through by hand, and you can hear it's just touching there. Now what I've done is I've actually turned this around in the chuck so several times into different positions, so I now know that as long as this machine face here is running true to the shaft which comes through here, this face will be true to the shaft. there is some play on this A plate here in the shaft, so there is some give. So we don't need to worry too much, but obviously we are worried about vibration and the effect of that will have on the bearings. But as long as this is machined true to the shaft here, then this face here is what's running out, not to the shaft. So what I'm going to do now is we're going to get some coolant running on here, and we're going to start machining this face. As I said all the way along, we need a tungsten carbide tip tool. You can't do this at high speed. You may be able to do it, but I wouldn't risk it because this is very hard, this face here. So we're going to get the coolant running, and then I'll come back and we'll start machining. Now the end game is to machine, just to machine these grooves. So the tool is just licking these grooves here and on this face in here, and that's when we get to the point when we can stop the machining. So let me get the pump running, and I'll be right back and we'll start the machining. Okay, so I don't know whether you can see here, but this is now, I'll just move the camera around here a little bit more, see if we can get a better view. So yeah, this is nearly cleaned up here, another cut or two, and that'll be ready to go. But this is tough old stuff. Don't forget your file to come and dress the sharp edge off of here. So we're now going to take the final. Okay, so we're going to take the final finishing cut now, and we should be there then. There we go. Let's take any burrs off the face. So that's it. Right, so what I'm going to do now is just pull this out so you can see it. Okay, so you can just see here now where the grooves were. Now this is where it's still case hardened in here, but this would be fine for it. Oh, sorry, to see. So you can see just where the grooves are now. So this is now fine for adhesing putting the adhesive on for the friction pad. So that's it. So that's the A plate. Sorry, I keep moving out of focus. That's the A plate. We can move on to the B plate now. So same process on the B plate. We're now just going to clean this plate up. This is going to be a lot softer than the A plate, as you can see here. Missing out now, so let me stroke the camera up. So you can see the B plate is a lot softer than the A plate. So I'm just going to take one more cut on here now. Completely different doing the B plate to the A plate. So I'm happy with that. Now what we're going to do with these plates now is we will put them on some on the surface plate and just lap them in to make sure they're absolutely flat. But yeah, I'm very happy with that. So we're good to start putting the friction pad on now. So I'll catch up with you guys in a bit when we're ready to do that. Okay, so we now got to the point where we're going to run these and make sure they're absolutely flat on the surface plate. As we can see now, we've machined this particular plate, but where it's been case hardened through the grooves, we've still got a case hardened element on these grooves, so they are protruding just slightly. This is what I go through normally. So the tool is actually pushing off when it hits these grooves when you're machining it. So what we're going to do is just put it on the surface plate now, and we're just going to do a figure of 8 with 120 grit paper. And we can see here now these high spots are disappearing. So we'll do that a bit further. So we can see now this is almost down now, so this is going to be good to put the adhesive on. So I'm going to do that a little bit more and get it flat, but I think I've set the scene for this video. I'm going to do the same with the B plate, but I'm going to use 600 grit on the B plate. So we'll catch up in a bit. Okay, so welcome back. So now basically both of these discs now have been basically finished flat on some basically some 120 grit on here to get this down. You can leave this 120 because the friction pad's being bonded to here, and that's good for the adhesive. So this has been taken down, just finished off with some 400 grit. There's a few slight score marks here from the tooling, but I'm not worried about that. That's not going to have no impact. Now the next thing we need to do is check that these discs are flat. So what we're going to do is we're going to put 4 cross marks down there with a dry marker. Now we've cleaned this plate off with a bit of tissue. Okay, and now what we're going to do is just rotate this round. Okay, we can now see that basically all of the marks have gone, so I'm happy that that plate is now flat. Now with this one I'm going to take a slightly different approach. I'm going to put a mark all the way around, okay, like a spiral, because as we know this tool was pushing this off in the hard spots here. So we're just going to have a look at that now. So we're just going to twist that round on there, and we can see we've got some high spots here and here, but you know the tooling is just touching here. So basically over 60%, this is absolutely dead flat, but the adhesive will make up and the pad will take that up in here, so I'm not too worried. So that's the whole point. We don't need to grind these to perfection. That's the whole point about using a friction pad. It will sort itself out when it's running, and it's not enough to cause any vibration in this environment. Anyway, we'll catch up soon. Okay, so we're now entering the final stage of the process now, which is basically bonding the friction pad. But before we do that, get some cellulose thinners or some white spirit and make sure that the surface of both the A plate is completely grease free. Now this adhesive is pretty forgiving. It's absolutely a killer when it comes to sticking, and it is a one-way street. So once this is bonded, this adhesive here, there's no solvent that will dissolve it. The only way is heat or to mechanically remove it. So this is a one-shot process. If you get this wrong, you have to order another pad. Okay. So there we go. So that's that plate now cleaned up. Now I will do this one as well. Now you have to press both these kits together. This kit together. So what you need is some 12mm studding, 75mm long, 2 washers and 2 nuts. Okay. So that's what we've got here. You need to preheat the oven to 200 degrees centigrade, whatever that is in Fahrenheit. I'm not sure, I'm afraid, but it's 200 degrees centigrade. So you'll have to go and do the conversion in the US to get that figure. So that's it. What you also need is an old toothbrush here. Okay. Now the adhesive is supplied in one of these little pots here. It's quite likely this may be stuck, so you might have to drill a hole in it to get it off. You know, it's early days yet. I've not sent any kits out. I left this overnight. I could unscrew it, but after a week in the post, who knows? So these are plastic little pots, so they'll be shipped like that together in a padded envelope. So that's that. So that's now been cleaned. Okay. So now what we're going to do is we're going to put the adhesive on the back of this pad here, and we're only putting it on the pad. We're not going to put it on here. Now what I'm just going to do is just check this is okay for size, which it is. Yeah, I'm happy with that. So it's exactly the same as the previous ones I've had. This is the new batch. So we're going to open this up here. Now this glue is horrible. If you get it on your hands, it's very difficult to remove. So this is the whole point of having the tissue and the toothbrush. So what we're going to do now is we're going to take a bit of adhesive out. It's like treacle and tar. And what I'm going to do is just going to put it on the back of the friction pad here. Try to avoid getting it on your fingers. I'm sure I'll get some on mine, but there we go. And you don't need too much of this stuff, because obviously the surface is flat. So I can't avoid getting it on my fingers. I'm trying to show you on the video I've got to do it this way. I would put it on the bench otherwise. There we go. So we want too much on there, because once it's compressed it will squeeze out. But we have basically an even surface across there. So you can see that is never going to break off. This is the same adhesive that's basically used on brake pads, as I understand. So what we're going to do now is we're now going to let that dry to the air for 10 minutes or so, and then what we're going to do is compress it between the two pads. So that's it for now. So once that's air dried for 15-20 minutes, we'll come back and we'll bond it, we'll compress it together with the studding. Okay, so we're getting to the point to bond this now. So I just really want to run through and summarise where we've got to. So these plates have now been machined. So we've taken approximately 1mm off of this face here, and between 1/2 and 1mm off this face here. So across the two dimensions here, we've reduced this by approximately 2mm. So now this pad here is actually 3mm thick. So what we're actually gaining is another millimetre of spring tension when we put this into a final assembly. So that'll then take up any reduction in tension of the spring over the last 40 odd years. So as I say, that's what I've tested, and I'm measuring mine round about between about 30.5mm my spring. So now this has now been left for 20-25 minutes or so. They do say 40 minutes, but I normally leave it about 20 minutes. So what we're going to do now is line this up on here. Make sure it's square around the edges, which is a perfect fit, as you can see, hopefully. And you can see it's a perfect fit around there. So now what we're going to do is we're going to put the B plate on top. Okay. And then what we're going to do is use this as the clamp. And make sure you bond it to the A plate, which is the one with the grooves, for obvious reasons. So I'm just going around here a sec, just making sure that's nicely aligned all the way around. Sorry, off the camera there. But you get the gist. Now what we're going to do now is, now we're all lined up, we're going to tighten this up. It doesn't need to be over tightened, but it needs to be tight enough. Because basically when you put this disc in the oven, what happens is the volatile chemicals in here evaporate off, and as they evaporate off they actually boil. So that's the whole point of clamping them together, to stop it pushing off. So there's a bit of residue coming around the sides here, but that is absolutely perfectly central now. So I'm happy with that. So that's, I'm just going to tighten this up a little bit more, and then this can go in the oven. Doesn't need to be over tightened, but tight enough. In fact, this washer is not central on here, so I'm just going to back this off a bit. Just going to double check it. That's looking good. So we can see now that that is now ready to put in the oven at 200 degrees centigrade, and we leave it for 45 minutes. So put a timer on for 45 minutes and then just let it cool down in the oven afterwards, and you should be good to go. So we'll catch up in a minute once it's completed. Okay, so this is out the oven now. So basically the first thing we're going to do is just remove this surplus glue on here. I should have done this when it was a bit warmer, but that would be my tip to you. But I've been doing other things. It's been a busy day today. Now what I would say to you is there's no chance of this thing coming apart. So that's it. I should have done that when it was a bit warmer. It's a bit softer then. So what we're going to do now is we're just going to remove the clamp. You can see it is just stuck here a bit. There we go. So two have come away. I'd probably use too much glue on here, to be quite honest with you, but that's trying to do it at the camera at the same time. So I'm just going to remove it on the inside now. tell you, this glue is exceedingly strong. There's no chance of this friction plate falling off, which is good, of course. And this material is specifically selected to work in an oil environment, so I've specifically selected that. So there we go, one finished clutch plate. So that's now ready for fitting. We can see there, you know, that's a lovely fit. And as I say, we've basically gained another millimetre in here, so that will provide a bit of extra tension on that spring. So this will never slip. So hopefully you've enjoyed this video, and we'll come back for the next one and look at catching up later on. But what I'm going to do now is, I've been through the whole day doing lots of things, shipping product out, getting this done, videoing it. So the final part of the day is actually to fit this. So we've got the usual plastic washer in the back here, the shim that sits behind. We've got in here the cage that sits behind the spring that goes over the primary shaft, and then we've got the springs. This spring sitting at 30 millimeters. It should be 31 off the top of my head. So the whole point about this modification is not only does it solve the metal friction plate, but it actually adds 1 millimeter depth on these plates. So when it goes in, you get a bit more tension. Now what I'm going to do is I will just lubricate this clutch plate, just not for anything else, but just in case that this engine stood for a while. I don't want it to go rusty. So just a little bit of oil on there. Now this alternator's been completely rebuilt, so I'm hoping that we will go straight in. I'm hoping we'll be able to catch a couple of threads on each one as we would if it was brand new, which we can. So we've got 4 or 5 threads holding on here. So the 2 at the top and the 1 at the bottom. So I'm hoping you can see this in the video, but it's just to give you an idea of how this is working now. So we're just going to start torquing this up evenly. It should go down nicely. There we go. Yeah, we're absolutely even. Do half a turn now at a time. So about 1 thread ain't now. Just coming up on the gasket. So there we go. One alternator complete and fitted. So that's it. So that concludes the alternator video, and it's working towards the finishing of this actual engine here now, which has been completely rebuilt from the ground up. So anyway, look forward to catching up soon, and I hope you enjoyed the rest of the video for those of you that want to see it, and we'll see you soon.